Hi everyone, today we are going to learn alpha, beta and gamma rays in 50 minutes. Are you ready? Let's start our lesson. By the end of this lesson, you should be able to explain alpha, beta and gamma decay equation with example without referring to the textbook. I'm sure all of you are familiar with the word of alpha, beta and gamma ray, right? Since you have learned briefly about radioactive material in your Form 3 science class. Now, I would like to recall and remind you what you have learned before. But before that, I would like to show you of this symbol. Have you ever seen this symbol before? And when you see it, what does it remind you? It is good if you know, but if you don't, you better be careful. If you see this symbol in laboratory or hospital or anywhere else, you better be careful because this symbol warning that it is dangerous and harmful. As you can see, it's written as radioactive material and you know that it emits radiation. However, not all radioactive material are harmful because sometimes it also benefit for us. Which means, in medical terms, radioactive radiation can treat the cancer by killing the cancer cell. Little did you know that how does this radiation exist? To answer this question, we need to learn about radioactive decay. So, let's continue our study. So, what is radioactive decay? Radioactive decay is a process in which an unstable nucleus becomes more stable by emitting radioactive radiation. Let's take a look at this diagram. This diagram shows the radioactive decay. Radioactive decay happens randomly and spontaneous, which means this process cannot be controlled and we can't predict what radiation it will emit. There are three types of radioactive radiation, which is alpha particle, beta particle, and gamma ray. As you can see in this diagram, this is a parent isotope or unstable nucleus. This unstable nucleus will undergo radioactive decay to produce daughter isotope or daughter nucleus which is more stable. And as you can see, there are three radiation that it emits, which is alpha particle, beta particle, and gamma ray. Now we will go through for every decay. The first equation we look at is for alpha decay. For alpha decay, the nucleus that do radioactive process will emit alpha particle. Thus, the process called as alpha decay. Alpha particle is a helium nucleus which consists of 2 protons and 2 neutrons. As you can see over here, the symbol of He have the mass number of nucleon is 4 and the atomic number of proton is 2. In this process, the unstable nucleus of an atom will disintegrate into 2 parts. The first particle is the daughter nucleus and the second particle is the alpha particle. As a result of alpha decay, the atomic number of the parent nucleus decreased by 2 and the mass number decreased by 4. This is because the atom X or the parents lose 2 neutrons and 2 protons to exit as a radiation of alpha particle. For better understanding, let's see the example of equation for alpha decay. As you can see, this animation shows the alpha decay of uranium-238, where uranium-238 have 92 protons and 146 neutrons with a total atomic mass of 238. This process made unstable uranium-238 emit an alpha particle which it lost 2 protons and 2 neutrons. As you can see in this general equation for alpha decay, thus for this uranium-238 decay, the equation will look like this, where the atomic number of new daughter goes down by 2 for loss of 2 protons and the atomic mass goes down by 4 from releasing 2 nucleons which consist of 2 protons and 2 neutrons. Thus, the resulting new element is the thorium, 2, 3, 4. As you can see, this thorium has 90 protons with the total atomic mass of 2, 3, 4. As the decay happens, the uranium changes to new element which is thorium 2, 3, 4. So this is the example of alpha decay. The second equation is for beta decay. Beta particle is a fast-moving electron where these particles are very small and move with very high speed. In beta decay, a neutron in an unstable nucleus decomposes or changes into one proton and one electron. The resulting proton remains in the nucleus while the electron is emitted with high kinetic energy as beta particle. Therefore, proton number of new nucleus will increase by 1 and the nucleon number remain unchanged. As shown in this picture, the parent nucleus will produce daughter nucleus and electron as a beta particle. For this, beta particle is the counterbalance to the positive charge of the proton, and in addition to this, a particle called antineutrino is also released. However, this antineutrino particle has no charge and does not have any significant mass either. Now, we take a look at the example of equation for beta decay. This animation shows the beta decay of thorium-234. Thorium-234 have 90 protons and 144 neutrons. Thus, the total atomic mass for thorium is 234. As the unstable nucleus of thorium-234 undergoes the beta decay, a neutron becomes a proton. As shown in this general equation, for the beta decay, the atomic number goes up 1 as the new element has an additional proton. The atomic mass stays the same as the new element has the same number of nucleons since the protons stay in the nucleus. One extra proton and one less neutron which have relatively the same mass, and the beta particle which is an electron is emitted as radiation. In this process, the resulting element is protactinium-234, which has 91 protons and the total atomic mass is 234, which is not changed. As you can see over here, thorium for the parent nucleus, which has the atomic number of 234, is still the same as the daughter nucleus for protactinium, which is 234. So, this is the example of the equation for beta decay. Our last equation is for gamma decay. Gamma decay, also known as gamma rays. Gamma rays are high frequency. That's one of the waves which has high frequency and is also called as electromagnetic wave. In gamma decay, an unstable nucleus which is excited nuclear state releases its excess energy to become more stable. Gamma ray has no mass and not charge, thus this particle is a neutral particle. This nucleus emits radiation without changing the original composition of the protons and the neutrons in the parent nucleus. There are multiple ways of arranging the proton and neutron in the nucleus which may have lower energy as compared to original arrangement. When this arrangement changes, it shoots out a high energy photon which are known as gamma ray, which does not have charge. Thus, the daughter and parent particle are the same. Here are examples of equation for gamma decay. Gamma decay for helium-3. Helium-3 has 2 protons and 1 neutron with a total atomic mass of 3. As helium undergoes a gamma decay, it releases a gamma ray. As it releases its energy to become more stable. Since gamma ray has no charge, the resulting element remain the same. As you can see, the parent and daughter nucleus has not changed. This is because that there is no proton or neutron loss in this radioactive decay. So this is the example of equation for gamma decay. Now, we will continue our lesson with radioactive decay series. So, what is radioactive decay series? When an unstable radioactive nucleus decay, the resulting total nucleus may also be unstable. Before this, we learned that unstable parent nucleus produce daughter nucleus which is stable. However, in this situation, the daughter are still not stable. Thus, the daughter nucleus will continue to undergo the series of successive decays until a stable configuration is achieved. In this process, the continuous radioactive decay will produce more energy and more radiation decay, which means alpha decay, beta decay, and gamma ray will repeatedly produce randomly. During this process, radioactive decay can emit more than one radiation, which means not only one radiation can be emitted at one time. Here is the example of decay equation. In this equation, we could see that from the parent of uranium nucleus, which have the mass number of 234 and atomic number 92, will produce the thorium daughter, which have the mass number of 230 and atomic number 19. It also produce helium, which is alpha particle, and at the same time, it will also produce gamma ray. So here, in this series, the nucleus, unstable nucleus will produce more than one radiation, which is alpha particle and gamma ray. We already learned about equation for all radiation. We should know that all these equations must be balanced. In nuclear decay reaction, you must be certain that all the combined atomic mass of the reactant equal the combined atomic mass of the product. Same goes to the atomic number. All of these must add to the same number on the reactant and product side. For example, you can see the alpha decay, the reactant of uranium, which have atomic mass 238. So the product must have add both the thorium and helium atomic mass to become 238. So here 234 atomic mass for thorium and 4 atomic mass for helium be added and we can get 238. So this means the reactant and product have balanced atomic mass. It also refers to the atomic number, which is 92 for uranium, and for the product thorium have 90 and for helium we have 2. So the equation is balanced. So we have done our lesson. By now you should be able to explain alpha, beta and gamma equation with the example, right? I hope all of you can. Before we end our class, let us summarize what we have learned today. So, we have learned about radioactive decay, which this decay happens randomly and spontaneous, which means this process we can't be controlled and we cannot predict what radiation it will emit. So, we have learned about alpha, beta and gamma. For alpha decay, it emits a alpha particle, which is also known as helium nucleus with the 2 protons and 2 neutrons. Then we also learn about beta decay. Beta decay releases an electron which called as beta particle, and this happens from the neutron becoming a proton. And last but not least, we also learn about gamma decay. Gamma decay emits a gamma rays which have high frequency and also known as electromagnetic wave. In gamma decay, it releases of energy as an atom to become more stable elements. So that's it. But before that, I have a surprise for you. Wait for it. Here we go. I have take home quiz for you. So the question is, radium 219 undergoes 5 times radioactive decay before it becomes stable plumbum 207. complete the equation for radioactive series for radium 219 below. So you have learned about alpha equation, beta equation, and gamma equation. I hope you can apply all these equations in this radioactive decay series. For discussion, we will discuss about it when we see you next time in our next class. So that's all for today. Thank you. See you next time.